So in this lecture, we're going to manage our users' passwords in the database. And by that I mean to first validate if the inputted password is equal to the confirmed password, and then also to encrypt the password in the database in order to secure it against attacks. And so the first thing that we're going to do is to validate if the two inputted passwords are the same. And the best place to do that is here in the confirm password. Okay, and so let's write our custom validator for that. All right. So remember, we use the validate property, and then since we want to create a function and also an error message, let's open a new object here, and then in there create validator, which is going to be the function, and let's actually start with this one. So remember, all we need here is to specify a simple callback function, which is then going to be called when the new document is created. So function, and here again, we cannot use an arrow function because we actually need to use the this keyword. Okay? So remember that from the validator function, we return either true or false. And if the returned value is false, then it means that we're going to get a validation error. Okay? And of course, if it's true, then not. And so what we want here is to say that the current element, so password confirm, is equal to this dot password. And that's actually it. So for example, if password confirm is ABC and password is also ABC, then this will of course return true, right? And so then the validation is passed and no error will occur. But if the initial password is, let's say, XYZ, well, then of course this is going to return false and we're going to have a validation error. Okay? So very simple, but we need to keep in mind that this is only going to work on save. Okay? So I talked about that before when we used the custom validator on the tour model, right? But I'm reminding you of that here again because this is absolutely crucial here in this point. Okay? So let me actually write it down here for you on save. Okay? And for this reason, whenever we want to update a user, we will always have to use save as well, and not, for example, find one and update like we did with our tours. Okay? So let's keep this in mind when we write the rest of the code throughout the rest of the section, and especially for updating. Okay? Because let's say that we updated the user's password simply with a regular update. Then in that case, this password confirm validation that we have here would no longer work. Okay? And of course, that cannot happen. Okay? And so again, keep in mind that this will only work when we create a new object, so on .create or on save. Okay? So on create and save. All right? So we create new objects using create, right? So right here, user.create. But remember how I also showed you that we can use user.save. Like this, right? And in fact, we can also use user.save in order to update a user. All right? But again, more about that a bit later. Okay? So let's now actually try out this validation here. Okay? So first of all, let's actually just try to create a new user with this data here, which should not work because we already have a user with this email address. And we said that this one should be unique, and so it should not work. Okay, and so of course we get our duplicate key error, right? Now if we were in production, then of course we already would get our nicely formatted error that we created in the last section, right? But right now we are in development, and so that's the error that we defined we want to see. Okay, so let's simply use another email here. And since we're working on the email here, let's also see how the email address validation works. So let's say that we specified this as our email. And so we see the error, please provide a valid email. Okay? So let's test it just like this, because I think that this should also not be valid. Maybe it is, but let's see. And yeah, actually it's not, because there are no domain names with only one letter. Okay, and so this validator is pretty specific, so it's really good. Now, if we do it like this, then of course it should work. But anyway, what we wanted to test here is these different passwords, okay? And I remember now that we actually didn't create an error message, I believe. And yeah, we didn't. And so let's add that here as well. So message are not the same. Okay? So let's add something here. Doesn't matter. And so now passwords are not the same. Okay? So perfect. And now, of course, our validation should be passed. And indeed, it is. And we created our new user. Let's head over to Compass here, take a look, and then actually delete it so that I can later create more users with the same email. All right. And we don't want all this junk here anyway, so all these test users. Okay. But now the next step is to actually encrypt these plain passwords that we are storing in our database right now. So as I mentioned in the last video, when we are working with authentication, one of the most fundamental principles is to never ever store plain passwords in a database. Okay? So that is something that's absolutely not acceptable. Okay? So we should really always encrypt users' passwords. Because imagine that for some reason a hacker gets access to the database. If then the passwords are stored in plain text in there, then he can simply log in as any user and then do whatever he really wants and cause a lot of damage in some cases. Okay, and so we need to absolutely prevent that. And so let's now go ahead and implement this. Now, where is the best place to actually do that? Well, I would argue that the model is always the best place to do this kind of functionality. So in this case, the encryption, because it really has to do with the data itself. And so it should be on the model and not in the controller. Okay, so again, keep the fat models, thin controllers philosophy in mind here. All right. So how are we going to now implement this encryption? Well, this is another perfect use case for using Mongoose middleware. And the one that we're going to use is a pre-save middleware. So basically document middleware. Okay. So remember, we defined that on the schema. Okay. And in this case, we want to set a pre-hook. So a pre-middleware on save. All right. And the reason why we're doing it like this is that the middleware function that we're going to specify here, so the encryption, is then going to be happened between the moment that we receive the data and the moment where it's actually persisted to the database. Okay. So that's where the pre-save middleware runs, between getting the data and saving it to the database. And so that's the perfect time to manipulate the data. All right. So a function, and then remember we have access to the next function in order to call the next middleware. Okay. Now we actually only want to encrypt the password if the password field has actually been updated. Okay. So basically only when really the password is changed, or also when it's created new. All right. Because imagine the user is only updating the email. Then in that case, of course, we do not want to encrypt the password again, right? And so we can do that with Mongoose. And so we're going to say if, and then this, which refers to the current document, right? And so in this case, to the current user, and then is modified. Okay, so we have a method on all documents which we can use if a certain field has been modified. And so here we need to pass in the name of the field. So password. Okay. And so basically what we want to do here is to say that if the password has not been modified, so not, then in that case, let's simply return from this function and not run any of the other code that's in here and then call the next middleware. Okay. So again, if the password has not been modified, then let's just exit this function and call the next middleware. Otherwise, we will then run the code that I'm going to put in here. And so now it's finally time to actually encrypt, or as we can also say, to hash the password. Okay, so you will see the term hash or hashing all the time And so that basically means encryption as well. Okay. Now we are going to do this encryption or hashing using a very well-known and well-studied and very popular hashing algorithm called bcrypt. Okay. So this algorithm will first salt and then hash our password in order to make it really strong to protect it against brute force attacks. All right. And so that's the whole reason why encryption needs to be really strong, because brute force attacks could try to guess a certain password if it's not really strong encrypted. And remember how I said that bcrypt will salt our password. And that just means that it's going to add a random string to the password so that two equal passwords do not generate the same hash. Okay? Makes sense? Now, I'm not going to go into all the cryptographic details on how this really works behind the scenes and why we need such a complex system. Okay? But of course, you can read all you want about bcrypt online. There's really a ton of interesting stuff to discover there. All right? Anyway, let's now go ahead and use the bcrypt.js package in order to use this algorithm. So npm install bcrypt.js. Okay, and so this basically is a bcrypt implementation for JavaScript. Okay, let's go back to our main terminal and then go ahead and import it here. And this one is by default only called bcrypt, okay, and not bcrypt.js. All right. And now let's actually use it. So we want to say that this .password, so the current password in this document, should be equal to bcrypt.hash and then our current password. Okay, and then in here we need to specify a coast parameter. Okay, and we could actually do this in two ways. So the first way would to be manually generating the salt, so that random string basically that is going to be added to our password, and then use that salt here in this hash function. All right. But instead, to make it a bit easier, we can also simply pass a cost parameter into this function here. And so that is basically a measure of how CPU intensive this operation will be. All right. And the default value here, I believe, is 10. But right now, it's a bit better to actually use 12 because computers have become more and more powerful. So like 20 years ago, you could have used 8 here and then a bit later then 10. But right now, at this point in time, it's best to use 12. And so the higher this cost here, basically the more CPU intensive the process will be and the better the password will be encrypted. Okay? And of course, we could go even higher, but then it would take way too long. All right? And I will show that to you in a second. Okay? But for now, let's actually finish this because there is one thing left here. So this hash here is actually the asynchronous version, but there also is a synchronous version. But as you already know, we do not want to use the synchronous version because that will block the event loop and then prevent other users from using the application. So just like we learned in the beginning. And so, of course, we want to use the asynchronous version, which is this one. And this will then return a promise. And that promise, of course, we need to await. And so we need to use await and then say that this function is an async function. Just like this. So let's recap that here. So we want to set our current password basically to the encrypted version of the original password with a cost of 12. Not to make it too easy to break the password, but also not to make the application take too long for encrypting the password. All right. So with this, we encrypted our password. And now in the end, what we need to do is to basically delete the confirm password. All right. Because at this point in time, we only have the real password hashed, right? So this .password confirm, and how we basically delete a field so not to be persisted in the database is to set it to undefined. All right. So we really only need this password confirm here for the validation that we implemented before. So just to make sure that user actually inputted 2 equal passwords so that he doesn't make any mistakes with his password, right? And so after this validation was successful, we actually no longer need this field. So we really do not want to persist it to the database. And so that's why we simply set it here to undefined. All right. Now you might wonder why this works, because we actually set password confirm to required, right? But that simply means that it's a required input, not that it's required to actually be persisted to the database. Okay. Now just to finish, we of course need to also call next. Okay, let's give it a save. And actually I'm going to add some comments here to make it really clear for you. So basically what this does is to only run this function if password was actually modified. Then here, hash the password with coast of 12, and then delete the password confirm field. Okay, and now let's go ahead and test this. And I will now create a new user with exactly this data, and let's now take a look at the result. And indeed, we now get this very weird looking password, which indeed is the encrypted version of pass1234. And also, as you see, password confirm is no longer here. Okay, and so just like this, we now stored users in a secure way in our database. Let me now just show you how it would work if we, for example, set it to like 16 here. And I need to change the email here. And so that should now take a lot of time. And I'm not sure if I can even wait. Oh, actually, yeah, it takes like 4.5 seconds. But that's still a bit too much, I believe. Okay, so let's set it back to 12. And so that should be better. Okay, and now let's just again delete these users here that we just created. And actually I need to get rid of this first one because this one still has the password in plain text. And so this user is not going to work when we start to actually log in users based on their password. Okay, so let's get rid of this. Okay, and also what I wanted to show you here is that we put in the exact same password for these 2 users that we created, right? But you see that the encrypted password is actually very different, right? And so that's the power of salting the password before hashing it. All right, so just like this, we again implemented a very secure and good password management.